Hi everyone, this is Ashok Kumar, Professor of Mechanical Engineering, Nanda Engineering College, Erode. In last video, I explained the construction procedure to draw the front view and top view of a line which is inclined to both the reference plane. So in last video, I just explained only the construction procedure to draw the projection of a line. But in this video, I am going to explain what is the concept behind to draw the projection of the line which is inclined to both the reference plane. So for this we have to first understand what is the effect of inclination of the line with the HP and inclination of the true inclination of the line with the VP on its projections. So consider, so I am going to take that first in this slide I am going to explain what is the effect of true inclination of the line with the HP. So I have taken that 4 examples here. This is the same line. So the line called AB of length say 50 mm. So in that case 1, the line is, so this is the reference axis, this is the front view and the top view of the line with the different inclination with the HP. In all the cases the line is parallel to VP. So I already told that if the line is parallel to the VP, the front view is projected on VP, so first we have to draw the front view. If the line is parallel to HP, the top view is projected on the HP, so first we have to draw the top view. So in this case we assumed the line is parallel to the VP, so first we have to draw the front view. So strictly we are following that first angle projections to explain the projection of line. So the front view is drawn above the XY reference axis, the top view is drawn below the XY reference axis. So in this case the line is parallel to both HP and VP. So here we can draw the front view at any above the we can start with the front view or top view. So here I am going to start with the front view. So assume that the line is parallel to HP as well as parallel to VP. The line is the distance between the line and HP and the line and VP are some distance. It is not necessary here, because here we are going to discuss the effect of true inclination of the line with the HP only. So this is the A dash and then this is the B dash. As the line is parallel to VP, the front view gives the true information. So the length of the line is, say, length of the front view is 50. So the line is some distance above HP, but it is not necessary to discuss. So here, so if you want, this is the distance between the line and the HP. Okay, as I already mentioned, while we discuss the front view, the XY line should be treated as HP. When we discuss about anything in the top view, the XY line should be taken as the VP. So here the line is parallel to HP also. So this is the top view of the point A, this is the top view of the point B, and the line AB is some distance, for example M distance in front of VP. The line is N distance above HP, that distance. So here as the line is parallel to HP, the top view is also the same 50 mm. So this is the case 1. Case 1, the line is inclined to both the reference plane. Okay. Now consider the case 2. So here I taken the same line of 50 mm. The line is parallel to VP. In all the cases, definitely the line is parallel to VP, and it is making 0 degree inclination to the HP, that is parallel to HP, on some small inclination with HP, for example 30 degree. So here the line is making 70 degree inclination to the HP. Now the line is making 90 degree inclination to the HP. In the 4 cases I am going to discuss. By discussing this one, at the end of this discussion we can easily tell what is the influence of inclination of the line, true inclination of the line with the HP. True inclination of the line with the HP is denoted by the Greek letter theta. For our convenience, we are using some notations, standard notations. So here the line is making theta degree, 30 degree inclination to the HP and parallel to VP. As the line is parallel to VP, the front view gives true information. So the length of the front view is equal to same 50 mm and then this is the A dash and this is the B dash. That angle made by the front view with the XY will give true inclination with the HP. Okay, now what is the top view? How to draw the top view? Assume that the line is parallel to VP. So this distance, for example M distance in front of VP, so the same distance will come below the XY reference axis after we rotate the HP 90 degree in clockwise direction. So the front view is already located here. To obtain the top view, project on vertical line over here, and then after the M distance we can locate the top view of the point A. Similarly we can locate the top view of the point B. Now if we measure, so the small AB is giving the top view length. Now definitely the top view length will be less than true length. True length is 50 mm, because when the inclination increases, the true length and the top view length decreases. Here the line is parallel to HP, so the top view also we will get the true length. Now the inclination of the line with the HP is slightly increased. Now the top view length is reduced a little bit, so definitely it is less than 50 mm. So now the angle made by the line with the HP is increased to 70 degree. Now this is the front view A dash and B dash. As the line is parallel to VP, the front view length gives the true length, that is equal to 50 mm. In this case also, that the front view length is equal to front view length is equal to true length, that is equal to 50 mm. So here the front view length is equal to true length, that is equal to 50 mm. Now we will find out the top view length. To obtain the top view length, project a vertical line from the A dash and the B dash. Then the point, the line AB is parallel to HP, which is M distance in front. So after the M distance, you locate the point here. So this is the top view of the point A, and this is the top view of the point B. Now we measure the length of the top view. So length of the top view, that is the top view length, will be definitely much less than the true length, because the inclination is high here, more here. Okay, now we increase the inclination of the line with the HP to 90 degree. So the line makes 90 degree to the HP, but still it is parallel to VP. As the line is parallel to VP, definitely the front view gives true information. The true information means the front view length of the line will be same as the original length of the line. So this is the front view of the given line. So the front view length is equal to true length, that is equal to 50 mm. 50 mm is that the original length of the line. Next, okay. Next, to draw the top view, project the vertical line from the here, or the observer is here to view the top view. So he can able to view only the point B only. Point A he cannot able to view, because the lines are perpendicular, because the races are perpendicular to the HP and parallel to VP, so the rays will touch only the point B. So this is the only point B is visible to the observer, point A is invisible to the observer, but anyhow we have some not A, but we have to mention that point A is there, which is exactly hidden by the point A. So we have to mention the point A within the bracket. It should be enclosed in the parenthesis. Now the B is the only visible. So right now the length of the top view, that is the top view length, is 0. So from here what we concluded is, when the line is parallel to the HP, the top view length is equal to true length. When the inclination of the line increases, the top view length decreases. When the line is making 30 degree to the HP, we are getting the reduced length in the top view. If we increase the inclination with the HP more, then we will again much reduced top view is obtained. When the line makes 90 degree to the HP, the entire line length is vanished, and then the top view length is becomes 0. So the theta is true inclination of the line with the HP is inversely proportional to top view length. Or on the other hand, the top view length is inversely proportional to theta. Okay. The next one is, what about the, so here we are going to use the the rotating line method only, we are going to fix the one end, we are going to rotate the other end till it satisfy the given question. For example, the line makes 30 degree to the HP means, and the point A is for example 10 mm above HP, and the line makes 30 degree means, first we have to fix the point A, then we have to rotate the point B till the line makes 30 degree to the HP. So normally we are going to fix the left end only, unless otherwise mentioned we are going to fix the one end. So that one end is the left extreme end. So okay, depending upon the other orientation, we are going to rotate the object by using the other end till it satisfy the given question. Okay, now the line is parallel to the HP, right? The A dash and the B dash both are lying in a same distance, right? So what is the so what is that B dash and what is this one? This is the distance between the point B from XY. This is the distance between the front of the point A and XY. This is the distance between the front of point B and XY. So both are same because both are parallel to the HP. So here, what is this one? 10, for example, 10 mm. 10 mm is the distance between the front of point A and XY. What is this one? This is the, for example, this is say K. What is K here? K is the distance between the front of the other end of the line B, that is B dash, to the XY. Okay, so this is what, for example, this is also I taken as a 10. So the 10 is fixed one. The point A is 10 mm above HP. The line makes 70 degree to the HP means we are going to keep the point A as fixed, because the position or location of the point A is given, that should not be changed. So the point A should be 10 mm above HP. The other end point B, the B from the HP we don't know, but we should make that the line should make 70 degree to the HP. So if you rotate the line by using the point B till it makes 70 degree to the HP, so this is the final position of the point B, right? So what is this one? This one is nothing but the position of the front of the point B from XY, or the location of point B from HP. For example, this is L, right? Then what is this one? This is the position of the point A from the HP, that is fixed 10 mm. What is this one? This one is the location of point B from the HP, or the position of the front of the point B from the XY. So this you take, this is the P. So here, when the line is parallel to HP, the position of point B from the HP is 10 mm. When the inclination of the line with the HP is 30 degrees, so here 0 degree, so the inclination of the line with the HP is parallel, so 0 degree, the distance is 10 mm. When the inclination of the line with the HP is increased to 30 degree, then the position of the B from the HP is increased. When we increased the inclination still more with respect to HP, the position of the point B from the HP is still increased. So L is greater than K. If the inclination of the line with the HP is 90 degree, then the distance between the point B and the HP is still increased. This is the maximum distance. So here the point K is less than L, which is less than P. On the other hand, P is greater, the position of the point P is greater than L, which is greater than L. That is nothing but when the inclination of the line, true inclination of the line with the HP increases, the altitude of the other end of the point will also increase from the HP. These 2 points are important points. Similarly, we consider this one. So here, this is the XY reference line. I consider the line. This is the XY. I consider the line same AB, which is equal to 50 mm. So here we are going to understand what is the influence of true inclination of the line with the VP. The true inclination of the line with the VP is denoted by the Greek letter alpha. So this is the case 1. This is the case 1. Here the true inclination of the line with the HP and true inclination of the line with the VP both are same, so that is equal to 0 degree. So the front view, this is the A dash and the B dash. So you can draw the front view first or top view first, no problem, because the line is inclined to both the reference plane A and B. So both are giving the true inclination. Now so here we are going to analyze about the effect of alpha in the projections. So here the front view length is equal to true length, that is equal to 50 mm, because the line is parallel to the VP. Now the line is making theta degree inclination to the VP. So the theta degree is nothing but alpha. The inclination of the line with the VP is denoted by the Greek letter alpha. So here the line is making some inclination to the VP, but still it is parallel to HP. If the line is parallel to HP, first we have to draw the top view, because the top view only give true information. So this is the point. So we can take this one. This is the point A and this is the point B. The top view length gives the true length that is equal to 50 mm. Right. Then this is the front view length. So front view length is definitely less than front view length is less than true length. Front view length is less than true length. Now you just still increase the inclination of the line with the VP. So increase the value of alpha. Say for example this is the 70 degree, right? But still the line is parallel to HP. So we can get the true length in the top view. So this is the A and this is the B, and so in this case this is the A dash and this is the B dash and this is the A dash and this is the B dash. So this distance is nothing but the front view length. The front view length is definitely much lesser than the true length. Now in this case the line is making, so this is the line A and then this is the line B. The line AB makes 90 degree to the, when we consider the top view, the XY line is nothing but VP. So right now the line is making 90 degree to the VP. So the observer can able to view, so the observer is here, right? So observer can able to view only the point B only. He cannot able to view the point A, because the point A is exactly hidden by the point B. So the length of the front view length is 0, because the line is perpendicular to VP. So here when the line is parallel to the VP, the front view gives true information. When the inclination of the line with the VP increases, the front view length decreases. So the front view length is inversely proportional to the value of alpha. Alpha is nothing but true inclination of the line with the VP. Okay. Now we are going to see what is the effect of alpha in the distance between the point B and VP. So here also the location of one point will be fixed. For example, the location of the point A will be fixed. Then the inclination of the line with the VP is given. So by fixing the A, we are going to rotate the point B till it make the orientation with the same as the question. Same in the question. So here the line is parallel to both HP and VP, the distance remains the same. But here assume that the line A is 10 mm in front of VP and the line makes 30 degree to the VP, means first we have to keep the point A at 10 mm in front of VP, then we have to rotate the point B till the line makes 30 degree to the VP. So right now, so this is the final position of the point B. So what is this one? This is the position of point B in front of VP, or this is the position of the top view of the point B with respect to the XY reference axis. When the line inclination of the line with the VP increases, the distance between the point B and VP also increases. Right now, for example, this distance is increases. For example, this is take it as a L and this is take it as a M. M is the distance of the point B in front of VP. So definitely M is greater than L. So because the inclination is increased here. Right now we are going to increase the maximum inclination. inclination, right? So here the inclination alpha equal to 90 degree. So the position of the point B with respect to VP is maximum. So this is take it as a n. So definitely n is greater than m. But in this all the cases, the phi value, the theta alpha value is increased, right? So when the alpha value increases, that the distance between the point B and the VP increases. So the final conclusion is when the true inclination of the HP is influencing on top view length and altitude of other end with the HP. So this distance will be influenced by theta value and top view length. So here when the line is parallel to the HP, then we are getting that maximum length. When the inclination of the line with HP increases, we are getting that reduced top view length, right? So finally the theta is influencing on top view length and the altitude of other end of the line. So one end is fixed, the other end is the rotating end, other end with the HP, right? So theta increases, top view length decreases. This is inversely proportional, this is directly proportional. Then what is the influence of alpha? Alpha is the true inclination of the line with the VP. So the alpha is influencing on the front view length and distance between other end of the line and XY or VP or XY. So this distance is influenced by alpha, and the length of the front view is influenced by alpha, right? Okay, now consider one problem. Now I am going to explain the constructional procedure. Now we can able to clearly understand what is the concept behind the constructional procedure. So consider the line AB of say 100 mm. The A is 10 mm above HP and 20 mm in front of VP. True inclination of the line with the HP is say 30 degree. True inclination of the line with the VP is, that is alpha, is 45 degree. Now we are going to draw the construction procedure. So first draw XY line. First fix the one end. A is 10 mm above HP. So from here measure 10 mm. This is the A dash. Then draw the location of the point A in front of VP. In front of VP is visible in the top view. The top view is projected on the HP. After it rotates, the top view will come below the XY reference axis. So this is the A. So A is 20 mm in front, A is 10 mm above HP. So first initially we assume that the line is parallel to the VP. If the line is parallel to the VP means the front view gives the true information. So what is the front view? The line is 100 mm long. It makes 30 degree with respect to HP. So from here draw a line which is in 30 degree inclined line for the length of 100 mm. Okay. So here the theta will fix the distance between the other end of the point from HP. So the theta is responsible to fix the distance between the point B and HP. So this is the B1 dash. So B1 dash is influenced by this 30 degree, that is the theta. So from here draw on horizontal line. So this is the locus of B dash. Next, we assume that the line is parallel to HP, and the parallel to HP we can able to see the true inclination with VP. So what is the inclination of the line with VP? 45 degree. So with the 45 degree we just draw an inclined line for the length of 100 mm, because then the top view length, because the top view length is equal to true length. So this is the 45 degree. So 45 degree, this is the alpha and this is the theta. Now this one, this is the point B1. What is, so here the alpha is responsible for the distance of the other end of the line B from the VP. So this is the responsible for this distance. Alpha is the responsible. Now you draw one locus here. So this is the locus of B. Now alpha is responsible for the front view length. Alpha is responsible for the front view length. So how do you find out the front view length? So this one. This distance is the front view length. This distance is front view length. You measure this distance and take the center as this one and make a arc here. So this gives the final position, final front view position of the point B. But if you do it, then it won't have any continuity. So for that we just extend. So this length is equal to this length. So this will give the front view length. Right, this is the front view length. You just measure this distance, then you take the compass and take the center as A dash and cut the arc on this locus of B dash. Now the A dash B dash gives the front view length. Front view length is nothing but this distance only, but it will not be a good one. So that you have to project a vertical line till it intersects the locus on drawn horizontal here line here. This is the locus of A dash. Make a project a vertical line from that B1, so till it intersects the locus of A dash. Now this distance and this distance both are same. Now take the center as A dash. So this point is say B2 dash, right? A dash B2 dash is equal to this distance. A2, for example, this is the point M, means AM is equal to A dash B2 dash. Both are equal to front view length. Take the center as A dash and radius as A dash B2 dash and make one arc here. So this is the procedure, that's all. So the front view length, to draw the front view length, it should be obtained from the top view. Similarly, the alpha, the true inclination of the line with the VP, is influencing for the distance of point B from the VP. So when we consider the top view, XY line is nothing but the VP. So the 45 degree is responsible for the distance of point B from the VP. Then the front view length, top view length, the top view length is influenced by the value of theta. So here this is the true length. No, draw one vertical line here, and this distance is the top view length. Right? You measure this distance and take the center as this one and radius as this distance and make the arc. But it is not in the continuous construction procedure. So that we are going to measure this distance only to make the continuity. We erect on vertical line till it intersects the locus of A. Now this point is say B2. AB2 is equal to this distance. Say this is the n. A dash n is equal to A dash n. Distance is equal to AB2. Both are equal to top view length. Right? So take the center as A, radius as AB2 and make one arc till it intersects the locus of B. Now that point gives the final top view of point B. So this is the final top view. So this is the procedure behind it. If we are strong in the property of this diagram, so okay, every time we need not imagine this procedure, and we need not waste the time by thinking how the lines are propagating from the another point. But if we are strong in the attributes of this final projections, we can easily do any type of projection of lines problem. Okay, in next video we are going to discuss two different problems by the simple method. Thank you.